Hey, sixth grade. Today we're talking about adding and subtracting fractions and mixed numbers. So we've talked quite a bit about fractions, about mixed numbers. We get a good sense of them, good idea about them, and I know you have some familiarity with adding and subtracting them, but we're gonna get right back to it and just do a little more practice. So get the name, your name at the top, date, title. Here we go. The notes you need today is that we need like denominators before adding or subtracting, so that we can count same size pieces. So this goes back to the fact that whenever we've added or subtracted before fractions, we typically been adding just numbers of whole units, and we just count them up because all the whole units we expect to be the same. But with fractions, we have things cut up into different size pieces, so we need to make sure that if we're going to count them all up, they need to be the same size pieces that we count. So I'm going to explain that in a second. The second part is that after finding a like denominator, which is a multiple of both denominators, if we remember, we create equivalent fractions. So really the first step, if you're adding fractions with like denominators, is to create equivalent fractions. So you're making a similar addition expression, it just has different equivalent fractions. So you're using different numbers so that they have like denominators. The last part is that we add and subtract like normal, but denominators stay the same. So even after we add or subtract our numerators, our denominator always stays the same. And the reason for that is because the denominator is just telling us the size of the pieces. We're not getting the denominator, we're not taking away the denominator. It's not something that we have, it describes the pieces. It tells us what size they are. So I want to show you this little picture that I have right now, and hopefully you can tell that this would be similar to adding the two fractions 1/2 plus 1/3. And some people will say, oh, doesn't that equal 2/5? They'll add numerators and denominators, and that doesn't make sense. Or they'll add 1 plus 1 and they won't know what to use as the denominator. So what I'm trying to make sure is that we never have to really feel like we're memorizing this rule. I want it to make sense. Why do we need like denominators when we add and subtract? And the reason is because we need those same size pieces. So even if I were going to say, well, how many pieces are, or what portion of a full box do you have here? We have 1/2 of it and 1/3 of it. You could say you have two pieces, but they're different size pieces. So I don't know what portion of a full box it is. Or 1/2 and 1/3. Well, what does that equal total? And the idea is what we do here is we create these like denominators to find a way to cut it up so that they have the same size pieces. So hopefully if you're familiar with those multiples, you know that halves and thirds both go into sixths. So what we'll do is we'll cut this, and again, we're not shading any portions. We're just creating an equivalent fraction by considering what portion of these boxes do we have, but we're considering it in a different way. So here we go. So you can see I multiplied each of those halves by 3. I'm multiplying each of these thirds by 2. I'm cutting them up to make more pieces. And now we have the same size pieces. Each one of these thinner boxes, skinnier boxes, is a sixth. So how many sixths was 1/2? It was 3/6. And again, that occurred because we cut each section into 3 boxes. We multiplied numerator and denominator by 3. What happened with the thirds? Well, each one of those thirds got cut into 2 sections. So the overall number of thirds that we have on the right-hand box is, or the overall number of sixths we have in the right-hand box is 2/6. Overall, if we added those together, we would have 5/6. And so it's easier to count things up when they are the same size. Now it makes sense to add these all up. How many total sixths do we have? We have 5 of them, and they're all the same size. That's why they can all share the same denominator. So that's a little explanation. Maybe it was a little overdone because that's already familiar with you. The rule makes sense, but I hope this makes you realize that, oh, it makes sense that we always need like denominators when we're adding and subtracting. This is a visual representation of why it makes sense. First example, if Cody can jump 16 and 5/12 feet and Mr. S can only jump 13 and 5/16 feet, how much farther can Cody jump? So first we just need to write these two mixed numbers that we're given. Cody can jump 16 and 5/12. Mr. Schwartz. And we're finding the difference. What's the difference in our jumps? What is the space in between? So this should be familiar as subtraction. I can jump 13 and 5/16. Now what we need here is we need a like denominator before we can figure this out. And one way that we can find like denominators is just by listing multiples of both 12 and 16. So we know that 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36, 12 times 4 is 48, and 12 times 5 is 60. Hopefully we're going to find a common denominator before we get that big. 16 times 1 is 16, times 2 would be 32, times 3 is 48, bingo. We found our common denominator. Both these denominators have a multiple, which is 48. They have a common multiple of 48. So what we're going to have to do is we're going to have to create equivalent fractions that have that denominator. So 16 and 5/12 will now become 16 and some number 48, and 13 and 5/16 will also become 13 and some number 48. So again, we're just taking this last extra bit we have and we're cutting it up so that we have a like denominator. We want the same size pieces. Well, what do we multiply 12 by to get 48? Because remember, if we're making equivalent fractions, we need to multiply numerator and denominator by the same thing. Well, we multiply 12 times 4 on bottom, so to make an equivalent fraction to 5/12, we need to multiply it by 4 on top, and it's 20. And if we multiplied 16, 16 times 3 was 48, so 5 times 3 will make us an equivalent fraction of 15/48. Now we can just do our subtraction like normal. If we have 20 48ths over here and we took away 15 of them, we would have 5 48ths left over. And now we can also subtract the whole units when we talked about this, just the fact that our mixed numbers have whole units as well. So 16 whole feet, and we took away 13 feet, that would be 3 feet. So Cody jumps 3 and 5 48ths feet, we should always include a unit, further. So that's our first one. Make sure you include that work. We're going to talk about other ways soon. We're going to talk about other ways to find like denominators, but for now, just listing multiples will work. Let's look at the next. The next one is just a problem here, and this one says 8 and 20 27ths plus 4 and 2/9. Now, again, we need those like denominators before we can add these two mixed numbers. So we need to think, what do 9 and 27 both go into? Now I could start listing multiples, but it's really important to always check this. You don't want to make the numbers bigger if you don't have to. And the fact is 9 goes into 27, so we can leave it at 27s. So 8 and 20 27ths will stay the same. We're going to add 4, and we want to make this mixed number. We need to create an equivalent fraction for 2/9 such that our new denominator is 27ths. Well, what do we multiply 9 by? We multiply 9 by 3 to get 27, so an equivalent fraction would have to have 2 multiplied by 3, or it would have to be 6. And then again, we're just going to add our numerators first, 20 27ths plus 6 27ths. Again, 27 just tells the size of the pieces. The total number of pieces we now have is 26 27ths. That's how many 27ths we have. And 8 plus 4, that's the number of whole units we have, is 12. So that one's a little easier. I'm just trying to point out that you always want to make sure you don't make the numbers too big if you don't have to. Find those least common multiples of the denominators. Find the least common denominator you can before adding or subtracting. So I'm going to leave you with some example problems as always. Here they are. The first one is, we're freezing. First one is 5/6 minus 3/8, so it's just fractions, no mixed numbers here. But number 2 says Lucille has already completed 7/20ths of a computer game. If she completes another 1/4 of the game tonight, how much will she have completed total? So figure out what operations you're doing there. Gave you just some fractions ones. We'll continue to do mixed number and fraction work tomorrow. But see if you can solve that word problem as well, and I'll catch you later.